Thanks to all of you for attending the conference. We're going to be wrapping up here this afternoon, but I really have to say I've been very much looking forward to this lunch presentation. I'm really excited to have Kristina Woolston here from Quintillion. And how many of you have heard of this Quintillion cable project? Awesome. Okay, that's awesome. Yeah, I think there's a lot of interest in this. I think this is a really important project for Alaska. And what's exciting to me is that this project is real. This is not a hypothetical project that might happen at some point in the future and bring, higher speed broadband telecommunications to bush communities. But this is actually something that's happening right now. And I, from my perspective, at least, it's been a project that's been under the radar quite a bit. So I'm really excited to have someone here that's going to sort out everything for us and tell us exactly what the current state of this project is. From my perspective, I think energy and the telecommunications industry, there's just so much interconnection between these two industries and we don't always recognize that. Better telecommunications, better broadband can result in more efficiencies in the power industry. And of course, the telecommunications industry is very reliant on having access to energy. And so from that perspective, I think it's very appropriate to have this presentation here. But the fact that we're going to have world-class services to several of our communities in Alaska, and that might actually be able to create a network to even more communities in the future. It's pretty exciting to me because I think that opens up all kinds of different opportunities for creative thinking around industry and connecting Alaska to a global economy. So thank you so much, Kristina. And now I have to introduce you personally, if you don't mind, because this is somebody that I'm very impressed with. Kristina, she was born and raised in Naknek. She graduated from Dartmouth with a bachelor's degree in government and actually got a scholarship from Naknek Electric Association. So that's your first interaction. So that's very, very cool, but came back to Alaska. And she worked both for Nova Gold for about 4 years or so, and then also for Chinega Native Corporation for 10 years in government relations. Is that right? Okay, maybe, yes, that's all relations, community relations, international relations, yes. So she's a pretty amazing person. I think that Quintillion's really lucky to have you on board, and we're lucky to have you here today, so thank you so much, and thanks to all of you for joining us.
Thank you. Thanks, everyone. Well, I would be remiss if I didn't point out some folks from home, Nathan Hill and Randy and Sandy Alvarez. It's nice to see some folks literally from home, so tell Mom and Dad hi. Thank you so much for the opportunity to speak today. I know that the project has been a little bit under the radar. We have managed that by design. One, we've had a very small team. We still only have about 11 people as employees and part of the management team. We're an Anchorage-based company. And actually, I should just advance to the next slide since we're talking about that already. There have been a number of projects like this that have been talked about and have been studied and have been considered and planned, and this is the one that's going forward, and we're very excited about that. We have been under the radar because we didn't really want to talk significantly about the project until we were well underway with construction, until we were, we had some significant milestones to report to the public, because it's an incredible project. It is one of a kind globally, and there's an awful lot of attention being paid to it. And we needed to make sure that everything was on the right track before we really started talking publicly about the project, getting people excited. I have 2 samples going around the room right now of cable itself, and that's not actual cable because the strands on the inside are just plastic. They're not the actual glass fibers that will be in the cable itself, but everything else is true to form, and the size of the fibers themselves are accurate. It's about the size of a strand of your hair. So getting back to Quintillion. Quintillion was founded by some Alaskans and a couple of folks outside of Alaska. We're based in Anchorage. We're, like I said, a very small team. Elizabeth Pierce, our CEO, used to be with CES, and she was actually for a long time, she worked on the radar sites, the Arctic radar sites, and so she has an awful lot of experience in Alaska and the Arctic, as does most of the team in Quintillion. We are privately funded by an investment firm out of New York, Cooper Investment Partners, and then we also have a couple of strategic Alaska Native corporations corporation investors in Alaska. But you'll hear the theme again and again, we are an Alaskan company. And one of the things that we're excited about is this is a privately funded project, which means that we really get to work closely with communities. We can manage the program to really suit Alaska's needs. And that also means that it keeps the cost down quite a bit for the end consumer. And the way that we've designed the system and we operate as a company is we are a wholesale provider. So we build the system and telecommunications companies buy wholesale capacity from us. And it's good for the communities because that will create competition. There are a number of Alaska companies, there are global telecom companies that are interested in the system. Because as you'll see in a minute, it's not just about Alaska. This is where we start, but it's certainly not where we end with the project. I think that's that for that slide. Wow, that is small. Sorry, that looks really small there. Let's go to that's interesting that the blue is not showing up very well. I'm gonna pass some maps around. How about that? I don't have enough for probably everybody in the room, but maybe one for every other person. And one map is the global network system, and then one is the Alaska system, and they're not that different. It's just one line to Tokyo, one line to London beyond Alaska. But what we're doing here, and I don't know if somebody's on can you guys zoom in at all? Nope? Okay, no big deal. So, yeah, gosh, I did not think it would be this small. I'm sorry, it seems so big in other places. So the system itself, phase 1 is where we begin, and it's under construction. We've been under construction since last year on Phase 1A, which is the Dalton Highway Project. And the Dalton Highway Project is fiber that we're running from Fairbanks to Prudhoe Bay, and from Prudhoe Bay we have infield fiber that connects at Iqaluit Point, which then heads out to the submarine fiber cable. The system is designed in a trunk and branch system, and that's significant because every single community has its own fiber connection. So it's not a daisy chain. So should anything ever happen to one community, it doesn't affect any of the others. It doesn't affect the trunk system. The terrestrial fiber and the entire system will be in service first quarter of 2017, so this time next year it will be in operation and in service. The fiber between Prudhoe and Fairbanks is about 250 miles, and it connects at Fairbanks to existing fiber, which connects down to the Pacific U.S. Northwest. So that's how the system is going to initially be connected to the World Wide Web. From there, from Iqaluit Point, it goes offshore to our trunk line, our subsea trunk line, with spurs and branches into Barrow, Wainwright, Point Hope, Kotzebue, and Nome. We are already working in Nome. We have about 1,500 feet of conduit that we're laying in town, which is significant. I'm sure many of you have been to Nome. It's a vibrant city. There is a lot going on. There are lots of people living there, and we have to lay a lot of the fiber in town, a lot of the conduit in town to run the fiber through when it comes ashore. So there's a lot of coordination within each of these communities, and it's something that, all of us in Alaska are doing this for the first time in this area of the world. And so we've got a lot of great partners in the communities that we're working with, the utility service companies and others, local government. The system at Nome, every community is different. We know that about Alaska, but when you talk about subsea fiber, it also has to play to the uniqueness of each community. Each shoreline is different. Each of the risk factors offshore are different. When you talk about submarine cables, the risk factors really revolve around either humans or, in Alaska's case, or the Arctic's case, ice. And ice scouring is a significant risk when you talk about submarine cables. So when we look at the shoreline of Alaska, and what's significant about the cables that you're seeing passed around is they are designed of the highest quality glass, cladding, double armored, the waterproof membrane around the outside of it. The system itself can withstand over 100,000 psi. So it is a significantly engineered system itself. And we designed it specifically for the Arctic because the environment is so unique. It's not like laying fiber, off the coast of Jamaica. The good thing is we don't have a ton of human interaction or people that would want to go to the seafloor in the Arctic and potentially disturb our system. So that's a good point. The other thing, though, is ice scouring historically in the Arctic. You can't tell if it's 10 months old or if it's 10,000 years old. And so when we did all of our surveying and looking at the seafloor, the geotechnical, geophysical mapping and surveying, we designed the system to go deeper than any historical ice scouring. So, for example, off of Electuc Point near Prudhoe Bay, we go down 4 meters, and we have to bring in a special ship with a special trenching machine, a hydro trenching machine, to accomplish that particular bore line into the shore off of Prudhoe Bay. In each community, we go down about 80 feet and go out a mile or two before the system comes up again and meets the trunk line offshore. So each community is different, but certainly a lot of thought has been put into this so that it's a very resilient system. I don't know what I did. There we go. So this is a little bit of the project. I talked about it quite a bit. It's a 3-pair system. So this system is going to start off at about 30 terabits per second. There's 3 fiber pairs. Each, will have a separate interconnection off of the trunk into each community. So we'll have branches right there at each one. The line itself has its own power supply, redundant terminals, and then we also have repeaters which boost the signal about every 3 to 4 meters. And the system itself, like I said, it's double armored and buried in shallow waters because of the risk profile in Alaska. It's about a 25-year life, but what we're learning about cables is there are cables that have been in the ground for 30 years already that are still in great operation. And that's 30-year-old technology. And so technology we're seeing today in 30 years will be that much better, and we'll be able to, the system over the life, turn it up as more capacity is needed. And you'll see in a minute, well, actually the map was before, you didn't see very well, the fact that phase 2 and 3 of this system is going to connect us to both Asia and to Europe, and it's going to connect Asia to Europe by the shortest route on the Earth, which is significant for each of those markets. It's significant for Alaska because we now have redundancy and a system that is repetitive, and it allows for our system to be backed up. It allows for diversity in routes. That's great for security. It's great for speed. It's also great for economic opportunities, whether it be data centers, and I'll talk about that in a minute, in terms of opportunities for Alaska. It's about 1,200 miles of subsea cable on the Alaska system, phase 1, and each community, yeah, I think that's it for the phase 1 Alaska. I've kind of beat that to death. Phase 2 Asia, that will extend from Nome to Japan. And at that point, we will likely have the opportunity to extend the network with additional spurs into other Alaska communities. Phase 2 Canada, UK, that will extend from Prudhoe Bay to the United Kingdom with opportunities for spurs into northern Canadian communities, which, like our northern Alaska communities, are incredibly remote and do not have adequate telecommunication systems. Many of the benefits to the community will start here. One, infrastructure costs, as you know, in the energy industry is incredibly high in Alaska. And fiber is the most cost-effective way to provide telecommunications if you can get it there. And this fiber in Alaska is kind of breaking the mold where we're bringing fiber into our shoreline, and then you can distribute the network, go the next mile into other communities that are even more remote. And so this is a great opportunity to bring fiber to communities that do not have, we do not have broadband in our rural communities. The baseline broadband is about 25 megabits per second. In a lot of our communities, it's about 6 megabits per second. The internet services that will be provided. I saw a recent article, the state of Alaska is hoping to use interpreters by using video teleconferencing. That's just one example of a great way we can provide additional services to our communities without physically having to move people in and out of our villages and other communities. It will also increase public safety, search and rescue, and it'll stimulate economic growth. We know that infrastructure is one of the critical tools for an economy, whether it be energy or telecommunications. These are some additional benefits that we've been looking at. Most of our communities are equipped with telehealth equipment, but they don't have the connectivity in order to utilize it. So we feel that that's one way that our communities will be able to receive almost immediate additional benefits that they're already prepared for, but cannot actually utilize because of lack of high-speed internet or broadband. Some of the opportunities that we see in Alaska. The Internet of Things and the billions of machines that are out there connecting other machines or monitoring a utility. Those are things that we don't necessarily have the ability to monitor and utilize from an efficiency standpoint in Alaska. And we think that is a real opportunity for our remote communities to, like our system, be able to monitor and change and adjust to the needs and services from a distance. Broadband will actually provide us the opportunity to do that. Demand is changing and growing, additionally by 40% at least each year. In some cases, it's up to 50 and 60%. We know Alaskans use more internet than our counterparts in the lower 48. So we know that Alaska, if they have the capacity, will probably adopt at a much higher rate and at a much greater percentage than our lower 48 counterparts. Alaska as a data center location, this will put us right in the middle of the shortest route between Asia and Europe. On the North Slope and in Alaska, there is land, there is power, and there is naturally cooling environments, which are one of the higher costs for a data center globally. So this, again, is another opportunity to look at for our communities for economic development and diversity. From an energy efficiency and monitoring standpoint, we do believe that the internet can be part of the solution. However, we are also part of the consumer because the system does have to be powered. And people using the internet or broadband use power. And so these are all things that need to be, I think, thought about in conjunction with each other. And when I was talking earlier about my talk today, rural infrastructure, I believe telecommunications and energy go hand in hand, and we can be incredible partners going forward because we believe that the internet can help utilities be more efficient, and we need energy in order to really maximize the potential for broadband in Alaska. Again, telecommunications drives energy consumption, and there's an awful lot of opportunities for our systems in Alaska to take advantage of the growing telecommunications needs. We're displacing books and classrooms and many other things. We're moving bits instead of people and parcels, and that's probably the way that it's going to continue to evolve. These are some of the pricing models for Alaska for broadband, or for internet, excuse me, because broadband isn't really available in a lot of the communities. And so this is one of the things that we've looked at. As a privately funded project, each of our individual phases of the project are financially independently viable. And so we have looked at this, and we think that we know that there's a good market out there for the services that we will be providing to the telecommunications companies. This is just a point of interest. We have a lot going on this summer, as I mentioned. Last year, the Dalton Highway project commenced, and we're right on track with that project. The submarine cable system install begins in June. It'll end in about September. We have our cable landing sites in each of the communities that are currently being constructed. We have to bring in an HDD ship in order to actually boring the cable onshore. We have a separate ship which has the cable segments. So there's going to be a lot happening, and we've taken great care to communicate and connect with each of the communities. But there's a lot that's going to be happening in Alaska this summer. A lot of the effort for the last year or two has been part of our plan of cooperation, our engagement with the communities from a subsistence standpoint, from a just general community activity standpoint. So we've got a lot to happen this summer. It's really just kicking off. Our first ship, really is in the waters right now, and so we've got an awful lot to look forward to this summer. And if you have any additional questions, you're welcome to contact me. I've got a stack of business cards there. That is the website address. That's my mobile telephone. You're welcome to call it. And I don't know if anybody has any questions right now, but I don't actually probably have enough time to take questions.
Well, actually, yeah, on the agenda, we're supposed to be asking AEA questions right now, but I think that we would like to take a couple for Kristina first.
Okay.
Anyone have one?
Oh, sorry, she got to him first.
It's just a general question because I know you're a private company, but what's the magnitude of cost associated with this?
So a number of people have asked this. There have been a variety of numbers out there, and we don't talk about the cost because we're still in construction, and a lot of things can happen, and we will talk about it afterwards, and there'll probably be a lot of lessons learned because it's the first time doing this in Alaska. But because it's a private company and because we're still in construction, we're not really talking about the cost. Oh, one thing I do want to add, thank you for that question, it prompted this. Over the course of time, Arctic Fiber, a company based out of Canada, was identified with this project, and that's probably a lot of the name that many of you have heard over time. When Cooper Investment Partners last year majority funded the project, they selected Quintillion as the company that will build and operate. At previous stages in the project, Quintillion was just going to be the company that had the exclusive rights to the U.S. landings. And so we're thrilled that it's really built around an Alaska company, and going forward, the only name you'll need to know is Quintillion.
Other
questions? You
questions?
had a question.
Oh, George?
So was there thought about bringing power cable with the comm cable?
So the cable system is designed with its own power system, and I actually asked our system engineer, each shore end segment has its own power supply, but the cable itself, and this is what he told me because I'm not going to rely on my own knowledge. So he said that Phase 1 will have 3 different PFE models capable of up to 3 kilovolts, 6 kV or 12 kV, depending on the future needs of the system. We can ramp it up, much like the capacity of the system, we can ramp up the power of the system. The current feed into the cable will be 1 amp, and expected Phase 1 system voltage will be less than 2 kV. So the entire wet plant runs on the same power as a typical hairdryer. Yeah.
A related question, I'm just curious, when we come ashore, is that also an opportunity? I'm not familiar with the last mile delivery of fiber, but would that be an opportunity to also consider a district heat network as long as we're underground?
In terms of power, is that what you're talking about? Oh, district heat. I'm sorry. I thought you said district T because we use T designs for a lot of our systems. So okay, district heat. I don't know, but I can get back to you on that. The onshore segment, so we come into onshore, basically it's a manhole, and then we deliver the fiber to the local provider. And then we have a system that runs from there. And so I don't know the answer to that, but if you write it down, I will find somebody to get you an answer.
Kristen, would you review again what I think I heard you saying about service beginning in the first fiscal quarter of 2017, and that will be a connection, an internet connection, worldwide connection from the south, and later on you'll be connecting with the cable to Europe, to Asia first, then Europe,
Yeah.
Phase 2 and Phase 3. Will there be a difference in the data transmission speeds? I assume it'll be a lot faster once you hook the big cable up, won't it?
It will be faster, and it will also have a diversity of routes, so a number of different benefits around that. So when the system is in Alaska, we are relying on the existing fiber systems that go down to the Pacific Northwest. So it's using systems that are currently in place right now. When the system, I've done this about 3 times now, sorry. When the system extends beyond Alaska, the speeds are, the system between Europe and Asia will have the shortest route, and so those speeds will be unique to the system. The speeds in Alaska will be virtually the same. So it'll be, we will have high-speed internet as soon as the system is turned on. The telecommunications providers will have the ability to use their capacity how they wish to with their service providers, so we're just selling on a wholesale basis. But yes, the system will have diversity, it will have redundancy once we connect outside of Alaska, so that is a significant next step in the project itself. So we can talk a little bit more about phase 2 in another month or 2. So we'll have some information to announce at that time, but not today. Thanks.
We have time for like one more question. Anybody else? Right here.
Does this also connect to the lower 48, or how does it connect?
Well, initially the system connects in fiber in Fairbanks here. Our new fiber connects to existing fiber through Anchorage and then down to Seattle and Portland, so that existing system that is already in place. When we go off to Tokyo and then to Europe, those systems will actually have a more redundant route or a diverse route as well. And so yes, initially it's just to the lower 48. Now one thing, and one of the reasons we designed it with 3 fiber pairs, is that we can dedicate one international to keep the information flowing between the 2 continents, but also from a national defense standpoint. We have all seen a tremendous amount of novelty and growing interest in the Arctic because we are the gateway to the Arctic, and this is only going to enhance our capabilities in the Arctic, is to have high-speed internet and broadband from either national defense, Coast Guard, emergency response. China Shipping, the largest shipping company in the world, about a month ago, they released a 240-page document giving their ships the routes, what the ice looks like in all of the Northwest Passage areas, so their ships can start trafficking that area more frequently. So it's not happening today. We don't have the vast increase in Arctic activity and shipping, but there are certainly plans to make that happen. We're seeing cruise ships, and cruise ships in Alaska are disembarking international passengers into our communities, and that's a significant security risk, because when you have somebody from another nation coming in on shore, at that point you're free to move about the country and you don't have to present any sort of international documentation. And we do not have Customs and Border Protection or Homeland Security in our rural communities because we don't have a presence there, but also we don't have the infrastructure capability from a telecommunications standpoint.
Thank you, Kristina. We really appreciate you taking the time to come here today and update us on the
Thank
project.
you.
It's really exciting, so thank you.